Hello and good morning, everyone. Today, I am going to review our midterm examination in differential calculus to see the right answers and the right solutions for each of the item. This is a multiple choice examination, and the first question goes like this. A teacher defines f of x equals 1 over x minus 3 and asks students to identify restrictions before graphing. Which response shows correct reasoning? Option A, domain excludes x equals 3. B, domain is all real numbers. C, range excludes y equals 3. And D, domain excludes x equals negative 3. So in this case, this is a rational function. So we are going to extract or use the denominator as the basis to get the domain. So it, let us set this, let us extract the denominator by equating it to 0. X equals 3. So now since we have figured out that 3 shouldn't be plugged into x, that means that the restriction is in option A. The domain must exclude x equals 3, meaning to say x must not be 3 in order for the students to be able to do the graphing. Number 2 question. A student claims that the domain of f of x equals the square root of x minus 5 is all real numbers. What misconception is present? The choices are ignoring denominator restrictions, ignoring negative radical restriction, confusing domain with range, misapplying exponent rules. So the correct answer from the choices or from the option is letter B. The student ignores negative radical restriction because when we get the domain of a radical function, the radical must be extracted and must be set as greater than or equal to 0, such as this. X minus 5 is greater than or equal to 0. And transpose on the other side, and that makes x is greater than or equal to 5. Therefore, the domain is not all real numbers, but it is a bracket since 5 is included, and infinity since it includes any number greater than 5. And that's it. The correct answer for number 2 is letter B. Number 3. A function models the height of a projectile h of t equals negative t squared plus 6t. What is the most appropriate domain in context? The options are all real numbers, t is greater than 0, t is greater than or equal to 0, and lesser than or equal to 6, or letter D, t is lesser than 6. So let us try to solve this given function. That is negative t squared, let us extract, minus 60. Since we can find a common factor from them, then we can factor them. Is it? That's plus negative t squared plus 60. Common is t. What is negative t plus 6? Let's set this to 0 again. Or 0. So this is automatically 0. So what remains is negative t plus 6 equals 0. Then let's transpose 6 on the other side. That would be negative 6. And then let us multiply them together by negative 1. I divide both sides by negative 1. Negative 1. Since t has a leading coefficient of 1, that is negative 1t divided by negative 1, that is positive t, and negative 6 divided by negative 1, that is 6. And since this is a projectile motion, meaning to say it will always start at a starting point. So therefore, our our answer for this is t is greater than or equal to 0. I know, t is greater than or equal to 0, that's right. That was correct earlier. And t is lesser than or equal to 6. So that is our answer for number 3. It's letter C. You can mark this if you want. Again, number 1 is letter A. Number 2 is letter B. And then number 3 is letter C. Now let us move on to number 4. A student sketches y equals the square root of x minus x squared. Which description of its range is correct? The choices are y is greater than or equal to 0, b is y lesser than 0, c y is greater than or equal to negative 2, and y is lesser than or equal to 2, and letter D, y is greater than or equal to 0, and y is lesser than or equal to 2. Now, in order for us to get the correct answer, let us try to extract the radical function. So we have it here. So let us have this function y equals the square root of x minus x squared. So let us try to find values that would set or that would result this function into 0. Or 0. So if we try to substitute 0 into this case, x minus x squared, that would be 0 minus 0 squared. And obviously that would result to 0. So the very first value that we can plug into x is 0. And that 0 is included to our domain. And we can also find other value that would make this function 0. So let us try to plug in 1. So 1 minus 1 squared, that is also 0. If we try to, that no longer makes this function because it can now be undefined if we try to. So in this case, since we have already obtained that our domain is 0 and 1, or x is greater than or equal to 0 and x is lesser than or equal to 1, we can now find out the range for it. So if we plug in 0, that gives us 0. And since here x is lesser than or equal to 1, then let us find values that will not make this 0 since we have already plugged in 0. Because if we try 1, that gives us 0. But since 0 is already here, then let us find other values that is lesser than 1. So let us try 1/2. So if we plug in 1/2 to x, that will be 1/2 minus 1/2 squared. And 1/2 squared is 1/4. So 1/2 minus 1/4, that is 1/2. So therefore, we can conclude that our range is y is greater than or equal to 0 and y is lesser than or equal to 1/2. That is for our range. So, therefore, for number 4, the answer is not in the choices. Since we have figured out that y is lesser than or y is greater than or equal to 0 and y is lesser than or equal to 1/2 for the range. Moving on to number 5, which situation best explains why domain must be restricted? So we have our options here. Option 1, when graphing linear and quadratic functions. B, when dealing with square roots or denominators. C, when using polynomials. Or letter D, when adding constants. So the correct answer for number 5 is letter B. It is when dealing with square roots or denominators. Number 6, a function is defined as f of x equals the square root of x minus 2 all over x minus 4. What is its domain? The options are A, x is greater than or equal to 2, B, x is greater than 2, C, x is greater than or equal to 2, and x is not equal to 4, or letter D, x is greater than 2 and x is not equal to 4. So in this case, since it is both a square root and a denominator, let us consider or let us extract the both numerator and denominator in order for us to consider the domain. So first, let us have the numerator. Let us extract x minus 2, and to set that, that would be x minus 2 is greater than or equal to 0. And all we just need to do is to transpose 2 on the other side. Therefore, um, the first thing to consider is x is greater than or equal to 2. And for the denominator, x minus 4, that would be x minus 4 equals 0, and then transpose 4 on the other side. So therefore, x must not be 4. And looking on to our choices here, it is obvious that letter C contains the right answer, which is x is greater than 2 and x is not equal to 4. So remember that in this case, both numerator and denominator must be considered or to be extracted in order for the domain to be figured out. Number 7 goes like the question goes like this. A teacher asks students to determine the range of y equals x to the second. One student says all real numbers. What is the correct feedback? The options are A, correct, B, only positive integers rather, C, all non-negative real numbers, or letter D, all negative real numbers. So the correct answer for number 7 is letter C, all non-negative real numbers. Number 8, which function has a restricted domain due to logarithmic properties? Letter A, y equals x squared, B, y equals ln x, C, y equals 2x plus 1, or letter D, y equals x to, I think this is to the third. The correct answer for number 8 is letter B. It is because the logarithmic function ln x is only defined of x is greater than 0, so it has a restricted domain. So number 8 is letter B, y equals ln x. Number 9. A student evaluates x squared minus 4 all over x minus 2 and gets 0. What is the error? Options are A, incorrect substitution, B, denominator is 0, C, limit does not exist, or letter D, should factor first. The correct answer for number 9 is letter D. The student must factor first, like the numerator, because x squared minus 4 can still be factored as x minus 2, and then cancel out x minus 2 from numerator and x minus 2 from the denominator. So it's not 0. The remaining factor is x minus 2, or the remaining solution is x minus 2. So the problem there is the student must factor first. Number 10. A teacher uses a table of values approaching x equals to 1. What concept is emphasized? A. Direct substitution. B. Algebraic simplification. C. Numerical approach to limits. D. Graphing only. So the correct answer for number 10 is letter the correct answer for number 10 is letter C. Numerical approach to limits. Let's talk about approaching or approaches to x equals 1. It simply talk about the limits because when talk about limits, these are the values approaching. These are the values approaching to the number that the x approaches, depending on the given function. Number 11, evaluate sine squared x all over x. So simply rewriting it, it means sine x times sine x all over x. And sine x, that is 0, times sine x over x, that is 1. So 0 times 1, that is 0. So number 11 is letter A. The correct answer for number 11 is letter A. Number 12. A function approaches different values from left and right. What conclusion is correct? A. Limit exists. B. Limit is 0. C. Limit does not exist. Or letter D. Limit is infinite. The correct answer for number 12 is letter C. Limit does not exist. Because when we see different values from left to right, meaning to say the limit does not exist because it must be the values must be the same. It's just that the the signs, it could be from the left, there would be negative sign, and from the right, it would be positive. So it must be the sign that's different, not the values. So therefore, number 12, the limit does not exist. Or letter C. Number 13, a student simplifies before taking limit. Why is this important? So in this case, among the choices, the correct answer is letter C. It avoids indeterminate forms because there are other factors that are not really that important. So it is so important to simplify the the answer for indeterminate forms to be avoided, and thus it gets us the simplified answer or the simplest form of the answer. Number 14. A teacher introduces derivatives as rate of change. Which interpretation is most accurate? A. Area under curve. B. Slope of tangent line. C. Value of function. Or letter D. Intercept. So talk about rate of change. And we remember that a tangent line, it is a line that passes through a one point of a circle. And by that, we can figure out that there is a rate of change in the slope of a tangent in the slope of a tangent line because there the rate of change occurs in the slope of the tangent line. So the correct answer for number 14 is letter B. Number 15, a function represents velocity. What does its derivative represent? The correct answer for number 15 is literally its acceleration. It's very, very common that the derivative of velocity is acceleration. From what I can remember in grade 12, the velocity has the units of meter per second, but in acceleration it becomes meter per second squared. So therefore, the derivative of the velocity is the acceleration. Number 16. Chain rule expresses A. Sum rule. B. Constant rule. C. Product of function. Or letter D. Derivative of composition. The correct answer for number 16 is the derivative of composition because chain rule, as far as I can remember, especially in the formula, it shows composite function. It is the derivative of composite function, which is f of x or x of f or g of x, something like that, that a function is inside the function. And that is what the chain rule expresses. Number 17. A function is undefined at a point but limit exists. What type of discontinuity is this? Among the choices, which are jump discontinuity, removable discontinuity, or essential discontinuity or continuous, the correct answer is letter B. It is removable discontinuity because removable discontinuity can be altered. It doesn't, just because it is discontinuous doesn't mean it cannot be altered. Removable means there is a function that can be altered, especially those that doesn't show any variable, since still the limit exists also. So therefore, it is a removable discontinuity, meaning to say it can still be fixed as long as there is a function that is going to be adjusted. So again, number 17 is letter B, removable discontinuity. Number 18, a student evaluates f of x using values less than 4. Why is this approach correct? A. It finds the average value. B. It determines behavior from the left. C. It simplifies the function. Letter D. It checks continuity. So the correct answer for number 18 is letter B. It determines behavior from the left. Because when we say less than 4, so the values are coming from the left. Because it doesn't say greater than 4, because when it says greater than 4, then it is the values that from the right. So therefore, these are the values from the left, or letter B. Number 19. A function is defined as f of x equals 2x plus 1x less than 15 minus x, and x is greater than 1. What is f of x? So the correct answer for number 19 is letter B. Evaluating the piecewise function correctly gives 2. It's just choosing the right function depending on the value of x. So since x is greater than or equal to 1, so we choose the function that is related to the given condition. Evaluating this function, it gives us the answer 2, so that is letter B. Number 20. A student evaluates 1 all over x minus 2 using a table of values and observes that the function increases without bound from one side and decreases without bound from the other. What is the most accurate conclusion? So number 20, the correct answer is letter B. The two-sided limit does not exist because one-sided limits diverge to opposite infinites. What is letter B? Number 21. A graph shows a vertical asymptote at x equals negative 1. What does this imply? Letter A, function is continuous there. B, limit is finite. C, function approaches infinity. Or letter D, function equals 0. So the correct answer for number 21 is letter C. Function approaches infinity. It's because simply a vertical asymptote means the function approaches infinity. So that is what a vertical asymptote implies. It doesn't just on negative 1, but also on other values, and it simply means function approaches infinity. Number 22. A student asks why dividing numerator and denominator by x is useful. What is best reason? A, makes function clear. B, changes degree. C, removes variables. D, simplifies behavior at infinity. So the correct answer for 22 is letter D. Dividing helps understand behavior at infinity. So it is so important to divide numerator and denominator by x, so that for us students, it would help us simplify the behavior of the infinity. Because if we will not do it, then it would give us a confusion about the behavior of the graph at infinity. Number 23. Which function has a horizontal asymptote y equals 2? So the correct answer for number 23 is letter B. Because as far as I can remember about horizontal asymptote, it depends on it has rules. I think when the degree of the square of the denominator is higher than the numerator, then it must be zero. But when it goes vice versa, meaning to say when the degree of the polynomial of the numerator is greater than from denominator, then there is no horizontal asymptote. But since y equals to 2, therefore we as we search through the right answer, there is other rule in which when if the degree of the polynomial of each function is the same, then the leading coefficient of each term must be divided. So figuring out, s- since there is 2x from the numerator and x on the denominator, there is also 2x all over x here, and I think it is more meaningful to answer letter B because it doesn't necessarily show a function, but I believe B is the correct answer. And it corresponds to 2x plus 1 all over x. Since 2x and x has the same degree of polynomial. So we are going to divide 2x by x, and that is 2. And that satisfies the question which function has horizontal asymptote y equals to. Number 24. A function is continuous at x equals a if a limit exists only, b function is defined only, c limit equals function value, or d graph is linear. The correct answer for number 24 is letter C, limit equals function value. Because it necessarily needs that the limit is equal to the function value for the function to be continuous. Because if it doesn't, then the limit will not exist, or the limit does not exist.
We are now in number 25. A function has a hole at x equals 2. What type of discontinuity is this? The choices are A jump, B infinite, C removable, or letter D is essential. The correct answer for number 25 is letter C. A function that has a hole is always removable, meaning to say it can still be altered, especially when function has no x variable. Number 26. A function has different left and right limits. What type is this? A removable, B jump, C essential, or letter D continuous. So in this case, since the left and right limits are different in terms of its value, meaning to say it is essential, meaning to say it can no longer be removable and it stays to be in discontinuity. Number 27. Which function is continuous everywhere? The correct answer for number 27 is letter A, that is f of x equals 1 all over x. Number 28. A teacher asks why continuity matters in real-world models. What is best response? A makes graph smooth, B ensures no sudden jumps, C simplifies equations, or letter D avoids limits. So the correct answer for number 28 is letter B. Continuity ensures no sudden jumps. Because a continuity, the graph shows that there is a continuous function and that ensures no jumps and no holes into it. Number 29. Which scenario best represents a jump discontinuity? Letter A, hole in graph. B. Vertical asymptote, C. Sudden change in value, or D. Smooth curve. So the best answer for number 29 is letter C, or the sudden change in value. And that makes a jump discontinuity from the term jump. The reason why it jump because there is a sudden change in value. Number 30. A teacher uses piecewise functions to illustrate continuity. Why is it effective? A. It shows multiple rules. B. Demonstrates behavior at boundaries. C. Simplifies graphs. Or D. It removes limits. The correct answer is letter B, or demonstrates behavior at boundaries. Because we know that piecewise functions shows different function um, according to the value of x, and with that it demonstrates the behavior at boundaries, since it shows boundaries and it shows whether the graph is continuous or not. And if it is not continuous, it could be removable or essential. And yes, piecewise function always shows behavior at boundaries. There we will figure out if there are jumps, if there is discontinuity, and we can locate which area does the graph makes discontinuous. Number 30. We are done with number 30, so let us move on to number 31. A student says derivative is just a formula. What should a teacher emphasize? So among the choices, the correct answer for number 31 is letter D. There should be graph interpretation, not just simplification, not just memorization and substitution, but there is an interpretation of the graph. It is not just a formula, but again, interpreting the graph in order to locate whether the graph is continuous or not. Moving on to number 32, a function is f of x equals x squared all over x plus 1. Why not simplify before differentiating? So, among the choices, the correct answer of number 32 is letter A. It is because if we simplify before differentiating, then it would change the function. Therefore, in order for the function to not be changed, then it must be differentiated first before simplifying. Number 33. A function models position. Its derivative represents. The choices are acceleration, velocity, force, and distance. The correct answer of number 33 is letter B. It's velocity. It's because derivative of position gives velocity. That's velocity. A student gets correct derivative but incorrect simplification. What skill is lacking? The correct answer for number 34 is letter D. There is a lacking of algebraic manipulation. Therefore, here I realize that it is not just about conceptual understanding, memorization, or graphing, but there must also be a algebraic manipulation in which algebraic processes must be applied, like factorization and many more, in order for the derivative to be simplified. We are now in number 35. The question goes like this. For y equals x sine x, find y prime. Among the choices, the correct answer is letter D. That is because we are applying the multiplication formula for derivatives. That is f of x times the derivative of g of x plus g of x times the derivative of f of x. So since the given function is x sine x, for the first case, f of x, which is x, which will be multiplied to the derivative of g of x, which is cos x, added with our g of x, which is sine x, times the derivative of f of x, which is 1. So sine x times 1, that is simply sine x. Therefore, our answer is x cos x plus sine x. And the correct answer for number 25 is letter D. Number 36, if y equals 5x all over x to the third minus 4, then dy over dx equals. The correct answer for number 36 is letter B. We are just simply applying the division rule for derivatives, which has the formula g of x times the derivative of f of x minus f of x times the derivative of g of x rather, all over gx squared. So we will just simply substitute the g of x and then find the derivative of f of x. So our f of x here is 5x, so that is 5. Therefore, that is 5 times x to the third minus 4 minus f of x, which is 5x times the derivative of g of x, which is 2x squared. So multiplying them together for the numerator, applying subtraction here, that results to 10 times the quantity of x cubed plus 2 all over x cubed minus 4 squared. So we will not touch the denominator because it doesn't it doesn't have a common from the numerator at all. So again, the correct answer for this is negative 10 times the quantity of x cubed plus 2 all over x cubed minus 4 to the power of 2. So this is simplified. So going back to our item, the correct answer is letter B. The answer on the other side was just simply factored. In here, it is not factored, but still the correct answer here is letter B. Number 37, find the derivative of 5x squared times the quantity of x plus 47. So in this case, we are going to apply the multiplication rule for derivatives. And with respect to its formula, given that would be f of x times the derivative of g of x plus g of x times derivative of f of x. So our f of x is 5x squared and our g of x is x plus 47. And now moving on to substituting each of the items, which is for f of x, that is 5x squared, and then for the derivative of g of x, that is 1, the derivative of x plus 47, that is 1, plus g of x, which is x plus 47, times the derivative of f of x, which is 10x. So applying all the operations together or combining like and unlike, combining like signs rather, it gives us 15x squared plus 470x, which can be found in letter A. Now let us move forward to number 38. The derivative of the function y equals 1 all over 2 sine times sine 2x is, so looking on to our Mathway formula, the correct answer for this is negative cos 2x CSC sine 2x cot sine 2x. So this is about chain power rules, in which there is two function involved, that in order for the next thing to do, the inside function first will be will be applied with its derivative. So with the chain rule, it gives us the answer negative cos 2x CSC sine 2x cot sine 2x. And I think it's not on the choices. Very, very complex to answer. It's not letter A. I'll just erase it since it's not on the choices. Hmm. Okay, so that's it. Just disregard that thing there because the answer is not on the choices. So moving on to number 39, find dy over dx given y equals x squared sine 1 over x when x is not equal to 0. So our function is x squared sine 1 over x squared sine squared x squared sine 1 all over x. 1 over x. So finding the derivative. So by using the math calculation, we have obtained 2x sine the quantity of 1 over x minus cos the quantity of 1 over x. This is through the use of the product rule, which is multiplying the function f of x, which is the x squared, times the derivative of g of x, which is the sine 1 over x, plus g of x, which is the sine over 1 over x times the derivative of f of x, which is 2x. And thus it gives us 2x sine 1 all over x minus cos 1 all over x. So let us try to locate the answer. What is the answer here? It's 2x sine 1 over x. 2x sine 1 over x. 2x sine 1 over x minus cos 1 over x. So the correct answer for number 39 is letter B. Now moving on to number 40, the derivative of the function y equals to x minus 1 all over 2 times the square root of x is, let us now try to plug it in to our math way. 2 square root of x minus 1 over 1 over 2 square root of x. 1 over 2, 1 over 2 square root of x. So let us now find its derivative. So the correct answer for this case is 1 over x to the power of 1 half plus 1 all over 4x to the power of 3 halves. This is simply using the chain rule in which there is two different functions and there is also inner and outer function. And by applying the chain rule, you have obtained 1 over x to the power of 1 half plus 1 all over 4x to the power of 3 halves. And locating its answer, the correct answer for this is letter B. So we can think of it since here it is not simplified into how negative exponent should be. So it is understandable that x to the power of negative 1 half can be 1 over x to the power of 1 half, and x to the power of negative 3 halves can be 1 all over x to the power of 3 halves. So number 40 is letter B. Number 41, if g
theta equals tan squared 5 theta, then g prime theta is equal to, so let's try to plug it in here, tan squared 5 theta. Tan squared 5 theta, tan squared 5 theta. Let's try to find the derivative of tan squared 5 theta by the use of math way. Tan squared 5 theta, let's check if it is tan squared 5 theta, tan squared 5 theta. And now finding its derivative. So this is applying chain rule. And by the use of the chain rule, the answer for the derivative of tan squared 5 theta is 10 sec squared times the quantity of 5 theta times tan 5 theta. Locating this, we can find it in the option. Letter C. 10 times 10 times 10 10 sec squared. I guess the choices is not here, but the closest one is, I think it's the letter C. It has that 10 tan 5 theta is the preceding one before the sec squared 5 theta. Tan 5 theta, yes it is. Tan 5 theta. They're just the same. It's just that in this case, tan 5 theta is the preceding one. So therefore, the correct answer for number 41, it's letter C by applying the chain rule. Number 42, if f of x equals 1 all over x squared plus 1 and g of x equals the square root of x, then the derivative of f of g of x is, so this is applying the chain rule again. Now let's try to plug in g of x to the f of x. For our x here is the square root of x. Since we're going to plug in the g of x of the x of the f of x. This will be squared a square minus the derivative and the derivative. So by applying the chain rule and the power rules in this case, it gives us the answer -1 all over x plus 1 squared, which can be found in the option letter D. It's simply, I just simply substitute the g of x, which is square root of x, to the x of f of x, which now becomes 1 all over the square root, or square root of the square root of x plus 1, and it gives us -1 all over x squared plus 1 squared. which is letter D. Number 43, find the absolute value of h all over h. Absolute value of h. So the answer for this is 0. So the answer for number 43 is 0. And it's not on the choices. Let's always try to evaluate it. It's 0. Again, number 43 is 0 and it's not on the choices. Number 44. Let f of x equals x squared minus 5 if x is lesser than or equal to negative 1 and x plus 4 if negative 1 is lesser than x and x is lesser than 2. 23. If x is lesser than or equal to 2. Find f of 2. So I cannot clearly get the piecewise function. But in this case, the formula to use is what satisfies the given function. So we are going to find the correct function that satisfies f of 2. Since it's 2, that is x is greater than or equal to 2. So we are going to apply the, I think it's x plus 4. So if it's x plus 4, then we will just simply substitute 2 into it to the x, which gives us 2. But I cannot clearly understand the piecewise function here. I will just try to see it clearly now. Number 44. Number 44 is letter C, that is negative 1. Since is f of x is 2. Let us find a function that satisfies f of 2 or x is greater than or equal to 2. I just can't clearly see what function is this. But the correct answer for number 44 is letter C, and that is negative 1. Number 45, for the function f of x whose graph is given below, shows the correct answer. So number 45, that is letter C. F of x is right continuous at x equals 3. Since as we can see from the graph becomes continuous at x equals 3. So though, yeah, it's x equals 3, and that's letter C. Number 46, the graph of the function f is shown below. Which of the following statements about f is true? Number 46, that is letter B. F of x is equal to 2. Which is just the same as letter C. It can be letter B or letter C. Number 47, for x is not equal to 4, the function h of x is equal to x squared plus x minus 20 all over x minus 4. What value should be assigned to h of 4 to make h of x continuous at x equals 4? Number 47, the correct answer is letter C. To make continuous, let us assign the value equal to limit approaching to 5. We will just simply apply this function x squared plus x minus 20, which can be simplified or which can be factored into x plus x plus 5, x minus 4. And then cancel out x minus 1, x minus 4, and x plus 5 remains. So simply, the correct answer is letter C. I think it must be negative 5, but I think it's still letter C. Number 48. The graph of y equals x squared minus 9 all over 3x minus 9 has A. Vertical asymptote at x equals 3, B. A horizontal asymptote at y equals 1 over 3, C. A removable discontinuity at x equals 3, and letter D. An infinite discontinuity at x equals 3. So the correct answer for number 48 is letter A. It has a vertical asymptote of 3. Since you're going to extract the denominator, which is 3x minus 9 equals 0, and then transpose negative 9 on the other side, and that becomes 3x equals 9, and then dividing both sides by 3, and that is equal to 3, as x is equal to 3, which is our vertical asymptote. And the correct answer for number 48, it's letter A. Number 49, second to the last. What is the derivative of y equals x all over the square root of 1 minus x squared? Okay, let us try to plug it to our pathway. Y equals x all over the square root of 1 minus x squared. X all over the square root of x, x all over the square root of 1 minus x squared minus x squared. Let's find its derivative. So the derivative of this function x all over the square root of 1 minus x squared is 1 all over negative x squared plus 1 to the power of 3 halves. By applying the quotient rule, x is our f of x, and 1, the square root of 1 minus x squared is our g of x. And we will just simply multiply the g of x, which is the square root of 1 minus x squared times x minus f of x, which is x times the derivative of g of x, which can be gotten from the square root of 1 minus x squared. So applying all the operations, it simply gives us 1 all over negative x squared plus 1 to the power of 3 halves. And of course, we have our denominator, which is remained untouched. And that gives us this answer. Locating this answer from the option, it gives us the end, the letter 1 over 1 squared plus 1 3 halves. So it's letter B. Correct answer for number 49 is letter B by just simply applying the quotient rule for derivatives. Number 50. Determine the points of discontinuity of f of x equals 3 all over x plus 2x all over x minus 4. So the correct answer for number 50 is letter C. Discontinuities occur when the denominator is 0, x equals 0, and x equals 4. So therefore, 50 rather is letter C. Discontinuity occurs when x equals 0 and 4. We will just simply look into onto the denominators of each of this function. X is literally 0, and then set x minus 4 into greater than or equal to 0, and then x minus 4 equals 0 rather, since this is rational function. X minus 4 equals 0, and then we will just simply transpose 4 on the other side. So therefore x cannot be 0, and so therefore x cannot be 4 rather, and x cannot be 0 as well by considering the first one here. Therefore, number 50 is letter C. And that ends our discussion for from the midterm examinations in differential calculus. And I have just found that I have taken so much mistakes in answering them together since it's a little bit complex. But I just learned the proper way of getting the chain rule, especially for trigonometric values. And it's just fun solving them all together. And that would be all. Thank you.